Okay, so now let's talk about the Fisher effect. Fisher effect is coming from Dr. Irving Fisher, who won the Nobel Economic Prize in 1973 for his contribution in the economic theory of a real interest rate. So under the Fisher effect, the nominal interest rate can be decomposed to the real interest rate and the inflation. This could be rewriting as the real rate. Let me use the Greek letter rho, stands for the real rate, and it is roughly the nominal interest rate minus inflation. And this equation is derived based on 1 plus the nominal rate equals to 1 plus the real rate, okay, times 1 plus the inflation. The nominal rate is what you hear every day from the news channels. The Federal Reserve announced to reduce the federal fund rate. That's the nominal rate. Okay, and the real rate is the interest rate taken away the inflation. Okay, or the real rate multiplied the inflation would give us the nominal rate. This is the inflation, and this is how could that apply in the international market? Let's say we have two countries, US and Japan. So if the Japanese real rate is greater than the US rate, then what would happen? We should know that when we're making our investment decisions, we should focus on the real rate, right? Because the inflation is something we don't want, and that could eat up our nominal return. So when we count how much we are better off, we're using the nominal return minus the inflation. Okay, so we are focusing on the real rate. That's number one. And the second, what about if one country like Japan has a higher real rate than us? Then capital would flow to Japan. So U.S. money, capital will fly to Japan. So the result would be there is a shortage of capital in the US, and there will be an oversupply of capital in Japan. As we discussed in the covered interest arbitrage example, if there is an oversupply, that's going to push the rate down. Okay, if supply is more in Japan, then the rate would go down. And if people keep borrowing money from US, that would push the US interest up. Okay. And once again, it is the real rate that we want to focus here, which is the nominal rate minus the inflation. Okay, so as a result, when the left-hand side is getting down, the right-hand side is getting up, then they will converge to each other. So there would be no capital fly anymore. So this will be, here's another example. If US interest is greater than the interest in Japan, of course, in real term, then it is the Japanese capital fly to US. All right, so people will borrow from Japan and then invest in the US. So the Japanese rate will increases because there's more and more demand of capital, and the US real rate will go down because there's more and more supply. The result would be, again, that both sides equalize each other, and then this capital flight will disappear. With that being said, we can set up another equation. So the equilibrium situation is the real rate in US denominated in dollar, okay, it equals to the real rate in Japan, all right? And I can do some algebra trick here, both added by 1, and the real rate of Japan plus 1 is the nominal rate of Japan divided by 1 plus the inflation of Japan. And likewise, the real rate of a US plus 1 is the nominal rate of US divided by the dollar inflation. All right, and then I'm going to connect these two parts. All right, so that's gonna give us the US interest over US inflation equals to the yen interest over yen inflation. And you can do another algebra work. Okay, the inflation ratio is the interest rate is the interest rate ratio. Okay, so that's what the Fisher effect applies in the international investment environment. Okay, and the presumption is that the real rate of the two countries equal to each other. And if there's a disequilibrium or a violation of this equilibrium, then the capital will fly from the lower rate place to the higher rate place and eventually make it converge. Okay, and that basically will equalize the inflation ratio to the interest rate ratio. Okay, so now we have covered the three parity relationship. Fisher effect is the third one, and before that we had purchasing power parity. We had interest rate parity. So in the purchasing power parity, we learned that the spot rate in the future equals to the spot rate now multiplied by 1 plus the dollar inflation over the foreign inflation. In this case, let me just use Japanese yen as an example. All right. And then you can see that the spot rate ratio is the inflation ratio under the purchasing power parity. Okay. And under the interest rate parity, you will see that the 1 plus the US interest, this is nominal interest, of course, with the inflation incorporated, it equals to the forward rate over the spot rate times 1 plus the foreign rate. Okay, again, let me use the Japanese yuan to represent the foreign rate. Okay, and if you rewrite that, it would be 1 plus the dollar interest over 1 plus the yen interest equals to the forward rate over the spot rate. All right, so we can see they share something in common. For example, the inflation ratios are mentioned right here on the top, and the interest difference here is mentioned on the top in Fisher effect. Okay, so now we can put them all together. The inflation difference and the interest ratio, and here is the spot rate ratio, and here is the forward over spot rate, and the spot rate is happening now. So as you can see that in the middle we have the Fisher effect connecting these two, and then on the right we have the interest rate parity connecting these two parts, and on the left we have the purchasing power parity connecting the spot rate and the inflation. Then what is the point? Why are we playing this math game? There's an implication here. All right, right here is a forward rate, and right here is the future spot rate. So based on the parity relationships, we would conclude that the forward rate is the best forecast of the future spot rate. Okay, that is that forecast is based on the consideration of inflation among two countries and also interest among two countries. And in this textbook, there's also some other format of this parity relationship. For example, let me use a different color here. In the Fisher effect, people would say the inflation difference is the interest difference. Okay. In the purchasing power parity, then we say the inflation difference is the change of an exchange rate, okay, which is S plus T minus ST over ST. That's the appreciation or depreciation of foreign currency, okay, yen. And under the interest rate parity, then the interest difference would be the forward premium. So when you connect the dot, so we have international Fisher effect, which equalized interest ratios to the spot rate change. Okay, so if you connect these two, spot rate change and interest rate change, then we would call that an international Fisher effect. Okay, if you connect right here the interest difference and this one, so this would give you international Fisher effect. Okay, so if you equalize the forward rate over the spot rate inflation ratios, this would give you forward rate purchasing power parity. And if you connect the forward over spot to the future spot over current spot, then you would reach forward expected parity. So you just need to understand these parity relationships, and you should know that the other three parity relationships are developed based on the first three parity relationships, which are interest rate parity, purchasing power parity, and the Fisher effect.